PowerPoint?
Yes. Yes.
Okay, good. Good morning, everyone, and good evening. And thank you very much for joining this webinars. Let's start this webinars. This is the call for participation webinars about the RDL Adhesion Strength Measurement and Characterization Project, Phase 1. This is today's agendas. Before we will explain about the project outline, let me briefly explain about the project choice and iNEMI project development process. Please mute your lines during the presentations. We will have a Q&A sessions after the project explanation. And please unmute yourself if you would have any questions. Okay, let's move on. This is project choice. Lisa Chen from Intel is a project leaders, and Carl Chen from iNEMI is co-leaders. And my name is Tzu Rios. I'm the facilitators of this project. This is the very brief process flow when we will develop the iNEMI project. First phase is to collect input or suggestion from the members or non-members. Well, we also get the suggestions, recommendation from workshops or surveys. Then we will define the project as they are planning the phases. Then we will develop the SOWs. Then we will start the project executions. There are several outputs. As the here's, it depends on the project objectives or goals. Then this is the typical 5 steps when we will develop the iNEMI project. We are now on between the step 3 and 4. Then once we will form the project teams, then we will start this project. So now we are explaining this project and looking for your participations. All right. Then here's I will pass to Lisa Chen. As I mentioned, she is the project chair. So Lisa, are you ready?
Yes, I am. Thank you, Masahiro-san. So thank you, everybody, for joining today. I will be talking about the purpose, problem statement, and objectives for this iNEMI project. So let's go to the next slide, please. So as background, I think for anyone who has interest in adhesion testing, there's some well-known standards. One of the main ones is this 90-degree peel test for trying to look at the adhesion of trace widths in current packaging systems, especially in organic substrates. As everyone, I think, here is aware, the design rules are going to ever smaller size scales, and so a standard needs to be able to be applied to these much smaller scales, and currently there isn't an established standard for doing so. Peel tests and shear tests are very commonly used to look at copper and other types of metal trace adhesion. But for some of the trace widths that we're interested in, even down to 8 microns, there's been a lot of difficulty in trying to apply these traditional techniques to do this type of testing. Some of the main risk areas include high risk of trace breakage and the limitations of the tools. So it would definitely benefit the industry to have a standardized way to do this type of measurement that everybody can use. So here's kind of just some of the pictures and schematics of what has been done before. And so now let's kind of go to the next slide to talk in more detail about this project. So the purpose is to evaluate adhesion strength measurement methods applicable to the redistribution layers for the fan-out wafer level packages, panel level packages, and advanced substrates, and characterize these RDL trace mechanical performance. This was defined in the technical gaps of iNEMI 2020, but on a higher level, it is definitely a critical need for the industry as the metal features become much smaller. This project is divided into a phased approach. This call for participation is currently for phase 1. Phase 1 will focus on looking at a variety of different methodologies and selecting a few to actually evaluate in order to measure the adhesion strength of features down to this size. Once we down select the most promising one or a couple, will validate the selected methodologies and develop the experimental guidelines to use. Phase 2 is when we would start applying this test to a wider variety of samples. We'll try to choose a fairly representative or common one in phase 1, but in phase 2 is when we want to start applying it and looking at different materials and interfaces and conducting a design of experiments. Okay, next slide. So there's probably two main approaches for how we plan on trying to solve this problem to find a suitable test method. The first one is looking at current existing adhesion testing methods and simply trying to scale them down. Here's a couple examples. On the left side is the shear test, and on the right is the peel test. And there's some dimensions here to kind of show what kind of scales that we're interested in, as well as some of the ideas. But essentially for this first approach of looking at existing methodologies, what we would try to do is improve the testing success rate and suitability for these small features. This may include changing the angle of approach. For example, instead of doing 90-degree peel, we might choose a different angle. Trying to control the bending angle during the peel or push or whatever sort of mechanical stress you place in order to make sure we measure adhesion and not other types of fail modes. This can also, other methods may include modifying the coupon design. And so an example for the peel test would be creating several fine lines in parallel and finding the average strength in this much more durable structure that can actually survive the peel test process. And then, of course, hopefully working with any tool vendor partners that will be involved in this project, looking at how tools can be developed to have more precise displacement control and load resolution to be more suitable for these types of materials. Next slide, please. But of course, in addition to looking at traditional methods, it's also a good opportunity here to start branching out and consider much more novel techniques, especially if they are much better suited for these type of materials. So kind of breaking away from the traditional force measurements, we may also consider strain-based measurements where we try to look at the difference in strain and induce delamination between the trace and the underlying layer. So what's shown on the left, but also we may try to do other types of methods that are much more suitable for thinner samples, especially if we're interested specifically in a flexible interface. Fatigue testing might be an example of that, of a suitable method. But essentially, this is also an excellent opportunity to explore novel approaches that are suitable for these length scales and that can deviate from the traditional methods we've talked about before. All right, next slide, please. So to be clear about what this project covers and what it will not, we are specifically focused on developing a methodology to test trace widths for RDLs below 20 microns. And we are focusing on evaluating different measurement methodologies. We are not going to be focused on developing new RDL materials of any sort, but in phase 2, we are open to applying the methodology that we develop to potentially test them if there is interest. what we hope to do in this project is to create recommended and experimental guidelines for the methodology, provide the proposed measurement methods to a standard body for global standardization, and then ultimately, if we move on to phase 2, to try to apply this, the down-selected method to a wider variety of base materials and metal interfaces. Okay, and next slide. So the anticipated benefits for this adhesion strength project are recommendations to a standard body for a global standardized test method, as well as a number of publications that will hopefully follow. As I mentioned, this project is divided into phase approaches, and this call for participation is for phase 1. Phase 1 consists of exploring different measurement methodologies and then down selecting the best candidates and developing that experimental procedure. Again, it is focused on developing the metrology itself. And part of that validation may be looking at one known good, no good adhesion case to make sure that difference can be detected. Once phase 1 is completed with some test coupon of choice that all the participants align on, then we start looking into phase 2, where a new statement of work and participation statement will be documented. This will be where we apply that methodology to start characterizing very different or a variety of base substrate and metal combinations. Okay. And so the outcome is that the experimental data will be shared among the project members. This will include the results and outcomes from looking at these different metrology options, the technical gaps on the metrologies as well, comparing the pros and cons. There will be a summary report for team members and an end of project webinar for iNEMI members. And we expect that there will be at least one paper or presentation at the end of this project. And of course, we do hope to come up with a recommendation to the industry and the appropriate standards organizations. So as far as the resources are needed, definitely, we are looking at support in 3 key areas. So for the test coupon design, for participants who are able to provide manufacturing capabilities, that would, of course, be extremely valuable because we'll have to explore a number of different designs and geometries to determine what may be suitable for the various techniques we will be looking at. And of course, running the actual measurement and evaluating the different methods will be critical. And in large part, the companies who participate, who are able to offer the evaluation capabilities, will actually, in large part, determine the options and what areas we can explore. And then, of course, doing the data analysis and making sense of not only the data that we get, but also making sure that the data validates known good and not good cases. Okay. And I think there's one more slide. Yes. So the plan for the project is that it will take a little bit over a year to complete the key tasks for phase 1. So these are fairly standard. Mainly once we start forming the team and defining the project phase 1 part, we will then actually start looking at different methodologies and then deciding which ones we will eventually evaluate to bring us all the way to the end. And as I mentioned, phase 2, as if there is continuing interest, will continue thereafter. Okay. I think that's the end. Thank you, Masahiro-san.
Okay, thank you very much, Lisa. Let me briefly explain how to join the project. Let's see, the screen mode. We have 2 documents. one is SOW's statement of work. This document includes the project scope, background, purpose, benefit, outlines, material, and the project schedules. And also the another document of the project statement. Then this project is only open for iNEMI members. If you're interested in joining this project, and if you're not the iNEMI members, so you are required to sign the membership agreement first. So if you have any questions, please contact the iNEMI staff. Then the sign-up due date is on March 15th. So if you're interested in joining this project, please sign the PS and send back to the iNEMI, any staff or myself. Then you also can download the document of the SOWs and PS from the iNEMI website. If you look at the RD and this project name, then you can find the project web pages. Then here you can download the statement work and also the project statement here. So again, due date is on March 15th. And we plans to start the kickoff meetings on March 17th from 10 a.m. Japan time. Then we will form the project teams. Then we will start this project. Okay. Now Q&A sessions. Any questions? Please unmute by yourself and ask questions if you would have. No questions?
Hey, Shira-san and Lisa.
Yes.
Hey, can
Ricky.
Can you hear?
Yes.
So for the sample preparations, do we have any candidates defined, or we still need to work through with the team and define the strategy?
I think we have some ideas, but what I'll say is there's kind of two aspects. One is the material combinations, and that I think will in large part depend on what the team that does form agrees is either suitable or of greatest interest to the group or the industry. As for the geometry of the sample, that's going to be largely dependent on the test methodology selected. It could potentially play a role in determining which methodologies we do want to evaluate. But it's open to definition. And I think in some part, it will also be open to capabilities of what our partners can manufacture.
I see.
Yes.
I think this is a very good one because as the traces and the copper flatness or roughness requirement get tighter, obviously that will trade off the adhesions, right? So strength and this kind of method would be good for material development, test development, to ensure that they have a very good test method to evaluate whatever adhesion promoters that they're trying to use here.
Yeah, definitely.
Thank you.
Thank you, Vicky. Any other questions? Okay. As I mentioned, that membership is required to participate in this project, but we also welcomes for your in-kind contributions. If you would have any testing services, then please contact me. Then I would like to work with you. Then if you can, provide your measurement services or materials, the raw materials, to supply. Okay. If no other questions, please don't forget that sign up due is March 15, so you can get all the document from this project website. And Lisa, thank you very much. And if you have no other questions, I would like to end this webinars. And thank you very much, everyone. And I'm expecting your participations and start working together from the March 17th. Thank you, everyone.
Thank you, everybody.
Thank you. Thank you.
Thank you.
Okay.
Thanks. Good job, Lisa. Thank you.
Thank you.
Right.
Thank you.
Thank you. Goodbye.
Bye.
Thank you.